All right, guys. Today we are going to start off by reviewing the two homework questions that we had out of the book last night from page 342. We had 18 and 21, and I want to go over those, and then I want to show you something else algebraically related to what we're going to be doing or what we've been doing recently. And then ultimately we're going to do the next section in our notes, which would be Chapter 8, Section 4, which is rather quick. And the rest of the time, you should have time to do your homework. Okay, so let's start off with these two questions. Number 18. It talks about taking a trip on a tour bus, and the tour bus has 40 gallons of gasoline, and every hour the bus is going to use 7 gallons of gasoline. The bus is going to stop for gas when there are 10 gallons left. So let's just model this scenario here to try to create a better look, a picture of what's happening here. Okay, and I have my bus. There's my tour bus starting off. So in your table that you create, I'll just create kind of a makeshift table below here. So we would say H, representing the number of hours traveled, is 0. And we're also going to measure the number of gallons that are left in the tank as time passes. So at the very start of this trip, you should realize that the tour bus has 40 gallons of gasoline. So when the time is 0, so I could put the time up above the bus even. So time is 0. The number of gallons left in the tank would be 40. Okay, simple enough there. Well, the bus is going to travel down the road an hour. So time is now 1 hour. And after 1 hour, or each hour it says, it's going to use 7 gallons of gasoline. So from the 40, we reduce that by 7 gallons, and now it's down to 33 gallons. This process continues again. Another hour passes. 2 hours have gone. We lose 7 more gallons of gasoline, taking us to 26. Passing along. 3 hours, and we're down to 19 gallons. So again, the bottom here is just your table. This is what your table is going to look like. Running out of room here, but this is fine because this is really all the farther I need to go. So 4 hours goes down to 12 gallons as we reduce it by 7 every single time. But it does say up here that they are going to stop when there are 10 gallons left. Well, we're currently at 12 gallons, and if we're reducing it by 7 every hour, there's no way we're going to get to 5 hours of traveling. So we will have gone a little bit farther here and then have to stop at that point. So part A should look like this. This is your table down below. If you wanted to take it out to 5, you could, but the problem with that is that you're down to 5 gallons, and they did say that they're going to be stopping for gas at 10. So you would have never actually made it to that point. All right, now you need an equation. So we've done these tables before, and we've analyzed these tables, and we say, okay, what's happening every time X value, or in this case the H value, increases by 1? What's happening to our Y value, or our dependent variable, which is the gallons? Well, it is losing 7 gallons every hour. So think about how we would do these. If we see that constant rate of change, we would be multiplying the rate of change by the number of hours. But since it's losing 7 hours, it's actually, we're reducing it or deducting 7 hours or 7 gallons per hour every single time. And we need to deduct that from the starting point. The starting point was 40 gallons. So we start at 40 gallons. Every hour we lose 7 gallons. We're not going to fill up again until that total number of gallons would be at 10. So this is the equation that you would want to write for part B. And then when we solve this equation, most of you I know would prefer to change this to add the opposite, so that then you could rewrite this as negative 7h plus 40 equals 10. And then algebraically, you take away 40 from both sides. And we get negative 7h equals negative 30. Divide both sides by negative 7. And we will reach 4 2/7 hours. So which that is about 17 minutes, about 4 hours and 17 minutes into this trip. They're going to need to stop for gasoline. Okay, but you didn't need to go that far. Just this part would be sufficient there. Okay, so that was 18. 21 presented a slightly different issue, or different problem for us. Sorry. Give me a minute here. I lost track of where I am. There we go. Sorry about that. Okay, so it's talking about having 3 consecutive even numbers whose sum is 30, and we want to write an equation for that. We don't have to, but I would prefer we do that because that's going to lead me into my next example here. But 2 consecutive integers would be something like 4 and 6. And it says it can be represented by like n and n plus 2. Okay, because to get to your next consecutive even integer, you have to add 2 to get to that point. All right, so if we have our first term at n, our first even number at n, our next even number would be 2 more than that. They want 3 consecutive. So our third consecutive would actually be the original n plus 4, because it's now 4 places away from that original n value. And that total sum should be 30. So here's your equation that would work for finding this first number. We've done problems like this before, but if you just look strictly at the left-hand side, all we have here are like terms that we're going to look to try to combine. So we combine all of our n values. And this side here is just going to clean up to be 3n plus 6 equals 30. And then algebraically, go through, let's solve it. 3n equals 4, divide by 3, divide by 3, and n is equal to 8. So that means that our 3 consecutive numbers, if n is 8, then that would start us at 8. 2 more than that puts us at 10. 4 more than the original 8 puts us at 12. Okay, so the 3 values that we wanted there were 8, 10, and 12. All right, so I wanted to show you something kind of related to this concept of solving an equation, how it can be applied. So I'm going to use this example here of a calendar. And you're going to work with me the best you can, and I know I'm not there to help you with this, but we'll see if we can make sense of this. What I'd like you to do is look at this calendar. I'm going to have you pause it here in a minute, but look at this calendar and pick any 4 dates that make a 2x2 square. Any 4 dates that make a 2x2 square. So for instance, 4, 5, 11, 12. That would be a 2x2 square. Or maybe you pick 14, 15, 21, 22, or 22, 23, 29, 30, etc. Okay? Just any 4 dates that create a 2x2 square. And then I want you to take the sum of those 4 dates. So add up the dates, the numbers, and get a sum. And there's a trick that I could show you if I was here with you, but there's a trick that if you told me the sum of your 4 digits, I could tell you what your 4 digits are right away. And no, I have not memorized every combination of 2x2 squares in the November 2018 calendar. This is an algebraic approach to doing this. So let's give it a shot. So pick any 4 dates. You can pause the video and add them up and get a sum. Okay. So hopefully you have a sum now. I'm not sure I'm going to guess the sum that you had, but I'll take a couple shots here. So let's say you picked out your 4 dates and you added them up and you got a sum of 76. Your 4 dates added up to 76. If I look at that sum of 76, I would tell you that your 4 dates are 15, 16, 22, and 23. You add those up, you can verify that that's true. All right. So a different set. Let's say you told me your sum was 40. If you told me your sum was 40, that must mean that you did 6, 7, 13, 14. All right? Let's go one more. How about 100? A little bit bigger there. If you picked 100, then that means you went with 21, 22, 28, and 29. This is really hard to do when I'm not actually here with you, because you probably don't even buy this. You probably think that, oh, he's just off to the side calculating these on his own and coming up with these numbers. But in reality, what would happen is you would give me these numbers. You would tell me the sum, and then I would tell you the 4 dates right away. And I'm doing this algebraically. Like I said before, I haven't memorized the November calendar. You can put any calendar up here. It doesn't matter. I'm doing this algebraically, and let me show you how. And hopefully you can kind of figure this out on your own. But if not, just follow along. No matter what date you start with, pick any date. Let's pick this N date right here. Call it the 12th. Okay, so my starting point is N. The very next date in your 2 by 2 square here, remember I said you had to make it 2 by 2. The very next date is the 13th, or N plus 1. You had to pick the number below the N value as well to make that square. So this 19 here, well, that number there would be 7 more, because it's a week later, than that first date. And then the number in the bottom right would always have to be 8 more than your original N value. Okay? So what I'm doing here is I'm adding these 4. I'm saying N plus N plus 1 plus N plus 7 plus N plus 8 equals your sum. Whatever you told me would go in that circle right there. So if I clean up this left-hand side, this is equivalent to 4N plus 16 equals any number. Now let's just pick the first number that I had there, 76. That was the first one I went with. And all I'm doing when I get these numbers, all I'm doing is just solving this equation in my head. So it does take a level of ability to do this mental math, but I would subtract 16 from 76 to get 60, and then you have to divide 60 by 4. 60 divided by 4 is 15. All right. Now I know this is not the 15. I was just using the 76 that I had before. So that's how I came up with this 15, 16, 22, 23. Okay? Now the dates that I have currently highlighted here, why don't we work with those? That would present a sum of what? 25, 45, 64. So if I tried that, I got 64 for the sum. And take away 16, 48. Divide that by 4, gives me 12. So there's my start date, which is actually what the first date is, 12. So then I knew it's 12, 13, 19, 20. Okay? Something different, just something that you could use or show people, but that would work every single time as long as they create a 2 by 2 square. All right, so let's bounce into our lesson for today. And I'm going to need you to get out your notes for this. I know you're watching this video and following along, so you should have your notes packet, the green one. And we're going to move into this chapter 8, section 4. And I'll try to get through this pretty quickly, maybe 10 minutes worth. And this lesson here consists of only 3 equations, 3 examples. They're just going to exemplify what we're trying to do today. If you look at the objective, We're going to try to write equations and solve them, but also write in this format right here, where it's a number multiplied by a quantity inside parentheses equal to another value. And we've seen these before already. I've presented this to you a couple of times, and we've been successful in solving these. So I have no doubts that we can do it again. It's just that we're going to practice writing them in this form too. All right, so let's dive right in here. Example 1. A bowling alley charges $3 to rent shoes. 4 friends each pay for 1 game and for renting shoes. Total cost is $28. Write an equation and solve for this situation. But I want to write an equation in the format like I have highlighted here. So just to clarify, 4 friends. Everybody's playing 1 game, and everybody's renting 1 pair of shoes. So they're all going to pay the same amount. I would like you to try to write an equation for this on your own before you hear my answer in this format up here. Okay? So challenge yourself. Pause the video now and see if you can do it. Did you actually pause it, or are you just listening straight through? Hopefully you did pause, and hopefully you have something in front of you. So let's think about this. In this format, this P times the quantity X plus Q equals R, this quantity in the parentheses, X plus Q, that's going to be multiplied by this constant outside, this P value. Well, if I read that critically, I would think that that number outside parentheses is going to be the number of times that I need to multiply this quantity by, of course, right? Well, in this problem here, I have 4 friends, and they're each going to pay the same amount of money. So I would think, by deduction, that 4 friends, my 4 should go outside of the parentheses, because I have 4 people all paying an equal amount, and that equal amount should go inside of these parentheses. Make sense? So let's see, what are each of the friends paying? Well, they're paying for a game, which I don't know how much the game costs, so that's right, that would be our variable, cost of a game. So there's my G. So they're paying for a game, G, and 1 pair of shoes. They've already said that it's $3 for those shoes. And then the total amount should be equal to $28. All right, good. Most of you, when you solve this equation, you're going to distribute first. I'm going to show you 2 different ways. Let's do this one in the black over here. So you're going to say, all right, well, I'm going to distribute through. I'm going to go 4 times G plus 4 times 3, which is 12, equals 28. And you're just going to work your way through, taking away 12, 4G equals 16. G is equal to 4, meaning each game is $4. And I know I went through that last part pretty quickly, but we've spent a considerable amount of time solving 2 steps, so I feel you're pretty comfortable there. I'm going to present you with a slightly different approach to doing this problem over here. I would like you to try to get rid of the 4 first. So we're not going to distribute first. We're going to try to get rid of that term outside of the parentheses. And that term outside of the parentheses is just being multiplied by that quantity. So we could do inverse operations here. I could cancel out this multiplying by 4 by doing its inverse and dividing by 4. And since I'm multiplying the 4 times this quantity, I don't have to divide the G and the 3 also by 4 because it's part of the same number, the same quantity. So in blue, I could just show that I'm dividing this by 4. Over here, I'll divide this by 4. And by doing that, I'm left with G plus 3, and 28 divided by 4 is 7. And boy, that looks a lot nicer than what it did 1 step prior to that. Cleans up pretty nicely. Now it's just a 1-step equation, and of course here we're just going to take away 3 from both. We get a value of G equals 4. Same as we did over on the left side, just a little bit quicker and a little bit cleaner and neater when we're doing this. So it proposed that a possible way to solve a problem that's set up in this form is to get rid of the variable, or get rid of the term outside of the parentheses by using this, they call it the division property of equality, which is simply just saying that if you divide one side of the number, or one side of the equation by a number, you need to divide the other side. It's just, it's balancing. We've been doing that for a while, okay? So the next one's already presented to you. You don't have to write it. But this one's going to really exemplify that concept I just showed you, that alternative method. Because when I get this 2/3 outside of the parentheses, I know how much you love working with fractions. So we're going to try to get rid of these fractions. So I can get rid of this 2/3 by dividing both sides by 2/3. Which we all know that dividing by 2/3 is the same as multiplying by its reciprocal 3/2. This is the route we're going to take here, because it's a little bit simpler, I think, in this case. So I'm going to show that I'm going to multiply both sides by 3/2. Divide. Okay, just do your cross-reducing there. But then I come over here, and I multiply this by 3/2. You might think, oh, this is looking a little bit ugly, but actually it's not. Because on the left-hand side, all of these terms on the left just kind of go away, except for your k minus 5, which obviously that's not very intimidating. But then on the right side, -4 times 3/2 would be -12 over 2, which is simply -6 when simplified. One-step equation. Add your 5. And we get k equals -1. Okay, so here's what I want you to try. K is equal to -1. Let me move all this. Here, I'll do this. Move all this over here. I'm going to leave that where it is. I'm going to get rid of all of the stuff up here. Now, what I would like you to try is solve this equation the other way. Solve it by distributing first. So go ahead and pause the video and do that. All right, have you given up on it yet? If you didn't, what's going to happen here is you multiply 2/3 times k. 2/3 k. 2/3 times 5 would be 10/3. Or if you chose to go to a decimal, you're looking at 3 1/3, which is equally ugly, equals -4. Okay, so already I like what it looked like on my first step over here a lot better than I do in the blue, but we'll see what's going on here. So let's get rid of the 10/3. So we're going to add 10/3 to both sides. Oh, man. Now we have an integer added to a fraction. So we need a common denominator. So you need to get a common denominator between these two, which would be 3, of course. So then -4 would become -12 over 3 plus 10/3, which gives you -2/3. So I have 2/3 k is equal to -2/3 down here. And then we're going to do that final step that we did up first up in the other side, is we're going to multiply both sides by 3/2 by 3/2. And yes, we are left with k equals -1, because these cancel out, and you're left with your negative here, but it's -1. There's not a person in here watching this video right now that wouldn't agree that this approach over here looks a lot better than the one on the right. Sure, you reach the same conclusion, and that's fine. There's just more chances for mistake, for error, by distributing in that case. Now, I'm not saying that you don't distribute. I'm not saying that. I'm not saying that that's not a great method. It is. It's a perfectly fine method. However, sometimes distributing does not lend itself to quicker, less messy solutions, if that makes any sense. So I just want you to explore it first. Look at the problem, analyze it, and see which way you think would work better first. All right, last one. Let's wrap this up. Same type of problem as number one. Tony buys 4 shirts at a clearance sale. We're assuming that each shirt costs the same amount. Each shirt is discounted $3.50 off the regular price. The total is $65. What's the regular price? All right, same thing. I want you to try to write it into the format like we had up above. So let's pause it and write it. Pause it. All right, I'm back. So looking at this, 4 shirts, like number one. The number outside the parentheses oftentimes means how many, well, all the time means how many of a specific quantity are we going to have. In this case, we're going to have 4 shirts. So I'm thinking 4 is going to go outside these parentheses because I'm multiplying the cost of every shirt by the 4. I don't know what the variable is yet. I haven't defined it, but it does ask me here, what is the price, regular price of a shirt? Well, I don't know what that price is. So that would be a great place to start for a variable. Call it P. But each shirt, the regular price is discounted by $3.50. So if I'm not paying P for each shirt, I'm paying P minus $3.50 for each shirt. The price minus $3.50 for 4 shirts, and the total here is going to be $65. All right, if you haven't solved it, try to solve it now. You can pause it and work it out. Okay, so when you look at this problem here, if we wanted to use that the division property of equality method where you divide both sides by 4, it's going to present yourself with a little bit of an issue. Not a big issue, but something that you may not prefer. When you divide both sides by 4, you're going to end up with a decimal on the right-hand side. Nothing too drastic, nothing that you can't handle. It's not a big deal, but just be aware of that when you do that. So you may want to distribute first. You're ultimately going to end up with the same answer, but let's say we just distribute first here. So I'm going to do 4 times P minus 4 times 350, which is 14, and that's going to equal $65. So then I'm going to add 14 to both sides. I get 4P equals $79. Well, divide both sides by 4. If this was 80, that would work out nicely, but it doesn't. It's close. So we're going to come up with, what is that, 19 3/4, so 19.75, since it's dollars, $19.75 for each shirt, regular priced, okay? But if we would have gone the other route and just got rid of the 4 first, so I'll go over here and do this, divide both sides by 4 to start, I'm left with P minus 350 equals, now 65 divided by 4 would be 16 1/4, 16.25. Yeah, because then when we add our 350, you're going to see that P equals 19.75, same as we got before. Okay, so I don't care. You might look at the one on the right and say, yeah, that's fine. I can do it that way. Good, do it. But these are just 2 different methods for taking apart that equation that we wrote. Okay, so hopefully that makes sense to you. I'm going to have you guys work on the homework problems here. And if you have any questions, come see me. All right, guys, have a great day. Bye.